Welcome back to Chemistry 1, Unit 5 Nomenclature. This is Lesson 2 on covalent bonding, video number 1. So we are going to be looking at the rules for naming covalent compounds in this video. So if you recall covalent compounds, we had nonmetals or metalloids involved with bonding. And we are going to look at two element compounds. That's all we're going to look at because there are millions of different possibilities for covalent compounds, and some of them have extremely large numbers of atoms in one compound that are all connected via rings and chains. There's even a new branch or another branch of chemistry called organic chemistry that deals with carbon compounds and the millions of different possible combinations of those. We're just going to look at two element compounds. So it's just made out of two elements. So for this one, our first rule is to name the first element using its full name. So if it is carbon, we would say carbon. If it was oxygen, we would say oxygen. So we use its full name. We're going to name the second element, but drop its last syllable and add the prefix IDE. So there's only so many non-metals. So if we look at them over here on this periodic table, and you should have a copy of this on white in your note packet, these ones have little charges up here that we're going to use. So it's very important that you have this periodic table, not so much this lesson, but in following lessons. So boron becomes boride, carbide, nitride, oxide, fluoride, silicide, phosphide, sulfide, chloride, germanide, arsenide, selenide, bromide, antimonide, telluride, iodide. So those are the ones that we are going to be changing. So our third rule is add numerical prefixes to indicate the number of each element present. Never use mono on the first element. And we'll get to that here in a second. So our prefixes, and these ones you have to know, but they're not that hard. 1 is mono, 2 is bi, 3 is tri, 4 is tetra, 5 is penta. So di, mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. And they actually do go further. So we could have these prefixes for anything. And some of these you probably remember from geometry, like pentagram and pentagon, hexagon, heptagon, octagon. We use them in all these different meanings. There's even a game called Tetris that is based on 4. Triangle. So we use these all the time. So let's look at a couple example problems. So if I ask you to name these, we would apply these rules. So our first one, we have C and O, carbon and oxygen. So our first rule says name the first element using its full name, so carbon, and add a prefix to indicate the number of each present, but we never use mono on the first. So if we just name the first element, if there's one of them, we just give it its full name. So carbon. The second one, we drop the last syllable and add IDE, so oxygen becomes oxide. And there's two of them, so we put a prefix of di in front of it. So carbon dioxide. If we look at N2O5, we have two N's. So we do have to use a prefix for this one, for the first element. So first element, we use its full name, so di goes in front of it, so dinitrogen. And then we have 5 oxygens. Well, oxygen as a second element becomes oxide. And 5 in front of it is penta. Now, typically, if we have a vowel on the end of this and our second element begins with a vowel, they usually drop the ending or the vowel off of this one. So this becomes pentoxide. If you write pentaoxide, I am not going to take off anything for that, but it's more proper to put pentoxide. So a lot of these have A's, or well, they all end in a vowel, but it's typical that they drop it, except for di and tri. So the A and the O, they typically drop them, as we'll see in this one. So we have CO here. It's only one O different than carbon dioxide, but on this one, again, we do not put mono in front of the first one, but we do have to put it in front of the second one. So monoxide becomes monoxide. We drop that O, so we don't have a double O there. Now, when we do the opposite of this, rules for writing covalent formulas, this one is just the opposite. We write the symbols for each element, and then the prefixes become the subscripts. And we never, ever, ever, ever write one as a subscript. So, if we have triphosphorus heptoxide, tri refers to 3. Phosphorus, the symbol is P. So we're going to have P with a subscript of 3. Hept refers to 7, and oxide refers to O, so O7.